Today I'd like to show you two of our prototypes from previous semesters. This prototype here was from the recent winter semester, and what my students have built is a device that can take a polyester drinking bottle, so a smaller version of this Pepsi Max bottle, and it can slice a strip out of the bottle that goes around in a spiral, and this strip can then be used. So the strip looks a little bit like this. It's then taken and it's wound together by the machine here into a rope. And my students found that they couldn't break this rope, and they could have a tug of war, and there didn't seem to be any problem with the strength of the rope. The way that the machine works, and the students were lucky here to find this aluminium briefcase, which used to have some telephony equipment in it. I think it had an antenna and various transponders and radio or telecommunications gear. I'm not exactly sure what it was, but it's a nice aluminium case that they found. And inside the case, they mounted an aluminium channel, which, if I can move the rope out of the way, you can see here. You should be able to see that there are 3 slits of different depths in this channel. And then mounted in the channel behind the slits, there's a box cutter knife blade. And this box cutter knife blade will slice off a strip of the from the bottle, which corresponds to the width of the slot here, the width of the opening. And the way that this is done is that the bottles are mounted here on these threaded rods, which lift up, and then the top is left on the bottom, on the bottle. The bottom is cut off, and then a small piece is started, so the strip is started using a knife, and a small piece is then pulled off the bottle, then placed through the slit here, which has the box cutter knife blade in, and then it's wrapped around this polypropylene waste pipe. Now, the polypropylene waste pipe is then driven by a battery-powered drill, one like, let me just fetch one. So it's driven by a battery drill driver, which you can normally use for drilling holes or turning screws and that kind of thing. So you'd put this here on the end of this shaft here, which is made out of a threaded rod that's then been ground on 3 sides to make it somewhat triangular, so that it will be gripped well by the chuck. And then this pipe rotates. It then pulls in the strip from the bottle, and the tension in the strip of polyester that runs across to the slot where it's cut is sufficient to keep the bottle turning and keep the cutting taking place. And that way, if it's correctly adjusted, you can actually turn an entire bottle into a strip within a matter of maybe 5 or 10 seconds. On the other side here, you can see that there are 3 eyes, and these eyes are mounted on bearings from skateboards and from skateboard wheels. And on the other side, there's a nut which can be placed in the chuck of the drill driver, and this can be used to drive this around. It will then twist 3 pieces of the polyester strip, and if you use this special wooden plate, which is then held so that it can't rotate, then it will gradually progress along the rope that's being manufactured as the 3 strips then wind themselves together. And then at each end of the rope, you have to then seal it using some tape or some heat shrink sleeving. One or two of the disadvantages that they found with this product, they found that obviously the short length of rope is difficult. If they made a future prototype, It's something where they could work on a method for, say, splicing the polyester ropes together, maybe so that the joints between the strips of polyester are not all at the same point, and maybe something which increases the friction between the strands so that the splice will hold itself together. And mostly the actual cutting was pretty good with this prototype. I think if this prototype were to be made entirely from scrap materials, it might be a little difficult to find this aluminium briefcase again, because this was test equipment from a laboratory. It's possible that there would be other kinds of containers, things like maybe ammunition crates, airline crates, that kind of thing, which could serve the same purpose. Or maybe even if you were willing to use a different shape, an oil drum cut in half, as people often do when they make a barbecue to grill meat. So I think on the whole this was quite a successful prototype. It's one I was very pleased with. It's one where the students also managed to work and plan their time successfully so that they didn't end up terribly short of time at the end. And my advice there would be, once you've decided on an idea in your team, you're not yet in your teams, well, that will happen in the next couple of weeks or so. You'll need to figure out how much it's going to cost to build your prototype, where you're going to get the materials from, and how long it's going to take you. If you're very careful in adding up the costs and the time you need, I would say at the end you need to add 50% to then get to a fair estimate of how long it will actually take. There are also one or two things in here which might not be so easy to find in a developing country. The thing I would mention to start with is the skateboard bearings. You might be able to get them, but you might find that they're also something that's quite expensive, maybe only available in cities, that kind of thing. And if your prototype is intended for use mainly in the country, then that's more difficult. The second prototype I'll show you today is this prototype, the plastic extruder. The plastic extruder is designed to take broken ABS plastic. This yellow plastic that you can see here came from a heat gun, a broken blower, and the purple plastic that you can see here came from a broken crate. So this is something that you can break up quite easily with wire cutters or pliers. It then is poured into the top of the cylinder here, and this cylinder was part of a pressure vessel for air conditioning or refrigeration. And this is then mounted on this hot plate, which has been cut out of an electric stove top. And they drilled a hole in the center of that so they could put a screw up through the center. They drilled it so that they had the right size hole to make a nozzle. And then when you turn this on, the hot plate here runs through a variable transformer that you can see here at the front, which they found from laboratory surplus. And the ABS plastic reaches about, I think it's maybe 200, 220 centigrade, something like that. The temperature was critical. And then this die stock at the top, which would normally be used for holding, I'm sorry, it's not a die stock, it's a tap wrench, a broken tap wrench, for holding a tap, for cutting a female screw thread. When this is turned, and then it rotates this screw thread, which pushes a piston down inside the cylinder, and it squeezes the ABS plastic so that the molten plastic at the bottom, some pressure develops in that, and it starts to get extruded through the screw at the bottom. The idea was to create a filament, a recycled plastic filament that was suitable for a 3D printer. The filament that they got at the end of this was maybe a little too irregular for a normal 3D printer. What they might want to think about if they were going to do this over again is, could they build a 3D printer that could cope with having a filament with a somewhat irregular diameter, or a filament with some kinks in it. The alternative, of course, would be to take this device, the plastic extruder, and maybe build it into the 3D printer, so that then you build a 3D printer that takes these broken ABS pieces and then melts those directly instead of needing a filament. And this is something, if you're interested in plastic recycling, and I think this is probably the third plastic recycling project that we've had in the International Design Project. You can think, well, how realistic would it be to build a 3D printer that uses granules or broken plastic? And maybe could you even design a 3D printer where if you throw in whole pieces of plastic covers and enclosures from computers and things, could the 3D printer actually melt these pieces or shred them, break them up itself, so that you don't have to buy the filament and you don't even need the filament? All you have to do is then, according to the marking on the plastic, then decide whether it's the right kind or not. Some comments about this design. I think they were very lucky to find the variable transformer down at the front. I think that's something that you wouldn't normally find in a developing country. Things like the wood here, the PC fan at the back for keeping the nozzle cool, the wall adapter that gives 12 volts for running the fan. These are things that you could easily find. Threaded rod and wing nuts. They would also be quite easy to find. Screws, pieces of metal, angle iron, that kind of thing. The tap wrench here might not be so easy to find, but you could improvise, you could find something else. The ball screw here was again from a laboratory. This was from some kind of linear motion rig. That would be something that would be quite hard to find in a developing country. You'd find threaded rod. The problem is, of course, that threaded rod then has a V thread form, which produces a lot more friction. This is a ball screw that has some ball bearings in it. What you might find is that you can get a square thread from a vise, either from a vise that you'd have on a workbench or from a vise in a big machine, maybe a broken milling machine or power hacksaw from the scrapyard, that kind of thing. I think on the whole this was a successful project, one that they also managed fairly well from a time point of view. And they even had time at the end to find some wood stain and stain all the wood the same color. And one disadvantage that they found was that it smoked quite a lot when you heated the ABS plastic to over 200 centigrade. So it was only really suitable for using outdoors or under a fume hood. That's again something that you might want to think about if you're building a second prototype, or for you, if you're interested in plastic recycling, you can think about that kind of thing from the beginning. I'll also show you a poster. This is a little older, and I don't have the prototype here today, but this is the Everpot, which is essentially a fridge which uses evaporation. It doesn't have to have an electricity supply to run. So what they did, the basics are that the water evaporates. There's a big steel tub that's wrapped in a towel, and the water evaporates from the towel, which has a large surface area. It also sucks up more water from capillary action. I think it's actually a long established concept in Arabic countries to have this kind of refrigerator. They made it out of scrap materials, and they also added a little solar panel and a fan. It was a project that worked very well, and I think it got down to about 4 or 6 centigrade inside the pot, even on a hot day. So you were probably looking at a 15 or 20 centigrade drop in temperature. So an impressive project. The one thing I'd say is you probably wouldn't get a functional solar cell easily if you were relatively poor in a developing country. I'd now like to tell you about your first assignment. It's broken into 2 parts. The first thing I'd like you to do is to create a small profile of yourself. So something with your name, hopefully with a picture, and with a bit of information saying what degree course you're studying. So mechanical engineering, electrical engineering, mechatronics, that kind of thing. what degree you're taking, so whether it's a bachelor's degree or a master's degree, and what stage of your degree you're in, whether it's your second semester, your seventh semester, or whatever. So we have an idea of the participants, and this will help me a bit when it comes to making teams. And it would also be good to know a bit about your interests. So maybe why you're taking the International Design Project, and what you want to get out of it, what you'd like to design, what your hobbies are, that kind of thing. It only needs to be maybe an A4 page, maybe less than that. The second part of your assignment, I want you to come up with 3 concepts. So 3 new ideas. At this stage, there are no rules. You can dream. They don't have to be practical. They just have to be ideas for things that would be useful and maybe possible to make out of reused materials in a developing country. So, and if you're sitting there and thinking, well, you know, I have no ideas, sit there and think, well, what would it be like? Read a bit about the countries, the kind of places where your project might be used, and think, well, what would these people find useful? What would make their lives easier? What would I want if I were then in their shoes? And I'd like you to do a sketch, a neat sketch of each idea that you have with annotations, so with some arrows and some labels saying what the parts do, and for each one, a few sentences saying what it is. It needn't be more than maybe sort of 30 or 40 words per concept. And what I want you to do, you should save these, if possible, in PDF format and upload them to the wiki area in StudIP. If you have any problems with that, then please send them by email to me and I'll upload them for you or find another way of getting them out to all the other students. So those are the 2 parts of your assignment. Firstly, a profile of yourself, and secondly, 3 concepts with annotated sketches, labels explaining what the idea is, how the concept works, what materials are reused, and then maybe 30 or 40 words per concept explaining what it does. I'd like these to be finished and uploaded by the 11th of May at the latest. If you have any questions about this, please contact me. It's supposed to be a fun idea. It's supposed to be a fun thing to do. You shouldn't really have any problems with this, and dream, come up with some crazy concepts. They don't have to be CAD drawings or anything like that. Simple pencil sketches are fine, and I look forward very much to seeing them. Thank you.